Hello everyone, how's everybody doing? Welcome to Rational Science. Why are we rational? Well, because everybody else is irrational. Either irrational or supernatural. If you look at the so-called scientific method that most people out there follow, it's what I call the mathematical method. It's not the scientific method, but the mathematical method, the M&M. They make an observation, they ask a question, they form what they call a hypothesis, whatever that is. There's like 10 different definitions for what a hypothesis is. And one of them is that it's a testable explanation. And what you won't find in mathematical physics today, anywhere, is explanations. Explanations specifically for the intangible, invisible phenomena that occurs out there. You know, light, gravity, magnetism. You won't find a rational physical interpretation. Anything at the cosmic level or at the, quantum level, the subatomic level. You won't find a rational explanation. And so the word explanation, this is not from me, this is by the way from another site, but they have this idea that there are explanations. No, there are no explanations. There are descriptions. That's all that mathematics can do. All it can do is describe. What is an equation? A description. It doesn't explain anything. Okay? So we don't have explanations. And that's the problem with the so-called scientific method all these people follow. It's really the mathematical method. They make predictions. I don't know what predictions have to do with science. Predictions, I thought astrologers made predictions, okay? And they test the predictions. They do experiments. And then they iterate. They use the results to make a new hypothesis or a new prediction. Or in fact, that's one of the definitions of hypothesis, that it's a prediction. So, all these people have this what they call the scientific method. We call it the mathematical method. Why? Because these people are not into explaining first, but second, they're only describing. But second, there's the issue that all of this has to do with persuading, convincing, converting, and recruiting people. That's all it is. This is about trying to influence the jury. That's all that this is for. This is to try to convince you that they're right, that they got the truth, that they found proof and evidence and all this stuff. We don't do that in science. That's what they do in religion. When you go on to Sunday school, they try to convert you. That's what this is all about. This is about converting people, not about explaining a phenomenon objectively. And it turns out that explaining a phenomenon objectively is regarded as, oh, that's philosophy. So here we have, what is it? A magnet attracts another magnet, okay? Okay? This is philosophy. Explaining this is philosophy. Why? Because you can't see the mediator? Is that why this is philosophy? It's opinion. That's all it is. All they do is mathematics to explain, to describe how fast or what force or how strong the attraction is. That's it. That's just a description. That's physics. Or is physics explaining how Mother Nature does this invisible trick? Or, you let go a pen, a pencil, pen. Let's see if I can do it with you watching here. Okay, so I let go of the pen, it's a pen, and it falls to the floor. And you can do the experiment at home every day. You'll see it always falls to the floor. You drop spoons to the floor. You drop cups, they fall to the floor. Is that philosophy? Explaining that? And that's what these people are saying. That's all philosophy. We don't do that. What we do here is math, and we call those descriptions science. So you describe a chair, 4 legs, a back seat, a backrest, and a seat, and you did science. Great. Now we do something else here. We try to explain, and here is the contrast to what these people do, okay? And here you can see it, rational scientific method. We have a hypothesis, an assumption, and it includes the object's definitions and the initial scene. Why? Because we're going to try to explain objectively to someone how Mother Nature does her invisible tricks. Okay, so the issue here is trying to explain. You can see they're a little different, these two scientific methods, so-called scientific methods. Theirs is mathematical. Okay, and then we go into the theory, the mechanism itself, the causes, and finally we reach some conclusions. Okay, so yeah, we have a different version of the scientific method, and we call that the rational scientific method. Okay. And what do we come up with as a result of that? Well, we come up with this. We come up with the rope model. We're saying that we ended up with a different conclusion. We're saying that every atom in the universe is connected to all others. All there is out there really is a single closed loop thread. And this single thread goes all around the universe through every bit of matter, every galaxy, every star, every planet, every asteroid, every atom. And this single thread just twines around in different directions, forms the atoms. Those atoms are obviously connected to the other atom. They're connected through a twined pair of threads, same thread. And the atoms themselves are made of these threads. And when the atoms expand and contract, they torque the rope, which is pulled tight. In other words, it's drawn tight. And by torquing the rope, light travels in both directions in what we call a torsion of the rope. That's what it is, essentially. That's what it all comes down to. Okay, and with this, as you can see, we can explain light, first of all. Okay, and second of all, we're going to explain also gravity. Here's the version of gravity. If all atoms are interconnected, then we don't need to use any fancy explanations out of the ordinary, you know, or saying, oh, we don't understand it. No, here you have a mechanism. As the astronaut falls down to Earth, the ropes fan out, and he goes at an ever faster rate. Not because the ropes are pulling. I want to make sure that people understand. People think that the ropes are pulling. The ropes are not pulling. As the astronaut occupies locations closer to the Earth, the ropes that connect every atom in his body to every atom on Earth, I didn't draw them all, they fan out. They're all at different angles the closer he gets to Earth. And that is the acceleration of gravity right there. Okay, so we have a mechanism for light. We have a mechanism also for electricity and magnetism and the workings of the atom, which are not shown there. But it gives you an idea that, yeah, we come from a different angle altogether. And here, I guess you can say, is the summary. Okay, this is the difference between what everybody else does out there, which they do with particles, whether they use waves or torsion, not torsions, but vortices. It's all either concepts or particles. And the concepts are founded on particles. A wave, transverse wave, is what? The movement, the waving of the particles. What's waving? Well, particles. Or you have to say what a lot of mathematicians say, it's the waving of nothing. They have to say some stupid thing like that. No, we're saying all atoms are interconnected and there is no waving up and down. What there is a torsion. You know, if this is the rope, okay, what we have is a torsion. And when you have a torsion, it goes not only fast and explains the speed of light, but it goes both ways. It goes in both directions, from atom to atom. My hands are the atoms in this case, okay? So if you torque that, obviously a little faster than what I can do here, the atoms expand and contract, torque the rope, and that torsion is what we call light. Very simple. Well, what has happened? Well, for the last 100 years, the religious folk have taken over science, and they just say, we don't understand it, but we've proven it. We've got equations, we have experiments, all this proves our theories. That's all they can tell you. But then they say, well, it's unimaginable. You cannot imagine four-dimensional space-time. You cannot imagine a particle being at two places at once, as the uncertainty principle requires or demands or entails. Okay? And so we have these people that have, you know, when we invented TV, all these people started doing shows for the public. And so these are some of the people who have gone in there. Give me a second. I'll turn this thing on. And here you have it. These are people who were on TV. I think they're all dead now, okay, but here they are. And what they did, you have people like Don Herbert, Jacques Cousteau, Carl Sagan, and Stephen Hawking. And what they did, they eventually passed on the baton to a new generation of people, okay? And let me get this. And the new generation essentially inherited the same thing that all these people did. Here's the new, or not the newest, but this is the next generation that inherited from these folks. Give me a second here. These people took over from that older generation, you can say. Okay, here you have Brian Greene, Neil Tyson, Bill Nye, and Jim Al-Khalili, a guy I've been talking about lately. Okay, and these folks are getting old, or are old now, and what they did is they turned the baton to a new generation of folk, and these are the new folks. You have people like Michael Stevens, Matt O'Dowd, Derek Muller, and Nick Lucid. And all these people are the ones who are now passing on the baton to the new generation. These are, what are they doing? They're explaining, and I hate to use the word explain because they don't explain anything, but what they're doing is passing on what they learned in college by rote without questioning, or even if they question, they finally were overcome by the arguments, and they just pass on what they learned, what they memorized to the public. And of course, in the last 100 years, they haven't invented anything, because the real solution was to get rid of the particle hypothesis. What has happened is they cannot explain anything. Why? Because they're using particles to simulate everything. And they say, well, you know, we can't understand it. Of course you can't, because you're doing it with particles, with discrete particles. And for sure you cannot explain pull, the force of pull with particles. What doesn't exist in all of quantum mechanics and all of general relativity, essentially, also in string theory, there's no pull. You have no pull. You have no way of producing pull because everything is mediated by discrete entities. And that's where the problem comes in. What they should have done is apply Popperian falsifiability and say, look, all these experiments, 100% of them, 150% of them, falsify the particle hypothesis. That's what they should have done. Instead of that, they created all these ridiculous principles, uncertainty, complementarity, and who knows what, you know, equivalence. Okay, so this is where we are at now. But it turns out because they don't produce anything new, they don't have anything new to offer, they had to invent new things for the new generation to do. They had to branch off, go on tangents that are not really related to physics directly, or maybe tangential. And one of those was the extinction of man, Doomsday. Okay, and so this is where they went. If I can find it here. There it goes. They went into Doomsday, and they used their equations to try to see if they can figure out when man is going to become extinct. Now listen to that. They're using equations to tell you, yes, we will become extinct, or we won't become extinct, and if we do, I'll tell you when, more or less. That's what this whole argument is about. That's what I'm going to be talking about today. The Doomsday Argument. These people claim that equations can tell them, because equations tell them everything, right? Tells them how the universe runs, tells them why the Earth doesn't fly out of the solar system. That's this warp time that's there, right? And yeah, because they can do everything with equations, they think they can also tell you when we're going to die, and when we're, you know, when we're going to be, when we're going to finish our days, our species. Okay, that's essentially what these people are saying. Okay, and for that they came up with this group of people, right? These are the people who today essentially spread the Doomsday Argument. Okay, and you probably recognize some of them from either TV or from YouTube or whatever. And again, you have some of them are the same people I just mentioned, Michael Stevens and this Matt O'Dowd. You have Nick Bostrom. He's supposedly a philosopher of physics, or who knows, of science, and he's much into the Doomsday Argument. And then Martin Rees, and there's so many people involved in this. I mean, if you look at the literature that has ballooned since about 1970s, in fact, really after the World War II, and I'll explain that in a second, it's ballooned. The number of papers written on issues such as the Anthropic Principle and Doomsday scenarios is simply incredible. And I'm not talking about unknown people. I'm talking about, you know, the high people that you would recognize their names if you've read a little bit about physics. So where did all this start? I think it started around World War II. Towards the end of the war, what happened? They had invented by then the atomic weapons. And for those who believe it, I mean, the flat earthers don't believe it, but for those who believe it, you know, they dropped 2 bombs in Japan. They killed lots of people, supposedly like 100,000 people in each city or so thereabouts. And what happened? Suddenly everybody got this idea that, whoa, we have the weapons to destroy mankind. See, until then, everybody just had, or at least the religious folk, you know, the traditional religions, they had this notion that, okay, Jesus Christ is going to come at the millennium or the second millennium and take all those chosen ones to heaven. So it was vague. It was, yeah, maybe, who knows. But now we had reality on our hands. Here we had this weapon, this cannonball that could destroy 100,000 people. And and so people said, oh, hold it. And then the Russians got it as well, the Soviets. And I was part of, involved in some of that, you know. And so now we had these 2 mafias, you know, on the one hand, the Soviets, on the other hand, the U.S. Government. And each one had the bomb, okay? And they were building more bombs. Eventually they built these missiles and so on. And now we have the ability to destroy mankind, you know, just by pressing buttons. And so, yeah, what grew out of that was this notion that we are a little fragile. We can't guarantee our existence because, you don't know, we get a crazy guy up there and he decides to press the red button and that's it for all of us. You know, we start exchanging bombs. So people had suddenly this notion that humanity was mortal. We were aware of our mortality as a species, that it could happen. We could really kill ourselves. And because of that, what happened was they invented this thing, 1947, they invented the Doomsday Clock, okay? And the Doomsday Clock was put in there because, yeah, every time there was tension in the political world, right? And Soviets did not get along with the Americans for some reason. People were scared, and they started moving that hand on the clock, saying, oh, we're closer to death for our species. And it's a 12-hour clock, and you can see that they don't even put buttons or markers for anything below 9 o'clock. It's from 9 to 12. It's like they move back and forth, like how close are we to pressing the buttons, okay, for nuclear extinction, in other words, by war, right? And lately, in fact, they moved it up. They moved it to about, if I can get it up here. Oh yeah, they moved the hand on the clock even closer, like 100 seconds from midnight or from 12 o'clock, right? So you know, they're afraid that not only the possibility of nuclear war because there are tensions in different parts of the world, but now they've introduced new factors. They said, oh, hold it, we have climate change and we're destroying the environment. And maybe there's a disease that runs amok, maybe made by the CIA, the KGB, or the Chinese Secret Service. And then, you know, and then maybe we invent AIs and so on. So the list for the Doomsday Clock has increased. And here's just a very brief list. Okay, nuclear war, climate change, environmental destruction, we're destroying the environment, cyber warfare, you know, we're playing around with the computers, all these, the CIA tries to break into the Chinese mainframes and vice versa, you know, so these people are all fighting the cyber war, trying to influence each other, maybe the elections or whatever, public opinion. And so all this makes people nervous, and the people who run the clock, they keep moving that hand back and forth, you know, like we're closer now to extinction, or now we're a little farther away. And one of the big ones lately, obviously, is this climate change. A lot of people are concerned about that. It's in the news all the time. Okay, so what happened? Around 1973, a fellow comes up. His name is Brandon Carter. I think he's Jimmy Carter's brother. And this fellow, Brandon Carter, he came up with the Anthropic Principle. And you say, well, what does that have to do with doomsday, with the end of man? And yeah, the Anthropic Principle essentially says that the universe is fine-tuned for life. Okay? That already gives you an idea that if it's fine-tuned for life, well, just maybe, right? Just maybe, it's also fine-tuned for death, right? Possibility there. And so what happened as a result of that? Well, about 10 years later, in that article that I just put up there, he talked about how the Anthropic Principle might be related to how much life there is in the universe. You know, there's this issue about Fermi's paradox that if there's some other life out there, we think that some of it at least should be older than ours and more advanced than ours, and so how come they haven't contacted us? Are we the only life in the universe? So Brandon Carter analyzed this issue. Like he said, you go to a planet, you find some people there or some life, and does that prove that life is very popular out there? Or are we in the same boat? We're saying, okay, now we have two pieces of evidence that there's life in the universe. Does that tell us that life is very widespread, or that life is a very scarce resource in the universe? What does it tell us? Right now, we're the only example we've got out there. And so we have one data point. And can you extrapolate much from that? Okay, so this is one of the issues, okay? But the fine-tuning took us to a different level. It was related to the doomsday scenario, to the extinction of man. You say, how so? Well, here's an example. This is from my website. I modified it a little bit, okay, just to give you an idea how some of the physical variables or physical relations out there do affect life on Earth. Okay, now I'll just give you an example here. Okay, and this is the example I have in my website, and it goes something like this: if the Earth is closer to the sun, right, or farther away, those two blue circles there, you know, if the Earth is closer or farther away, well, we have more heat or less heat. If it's outside of the ecliptic, the Earth is outside the ecliptic, you know, maybe that has an effect on life. Maybe if the tilt of the Earth is different, maybe if it's got a different magnetic field or none at all. The sun size, if the sun were bigger or smaller. The mass of the Earth, right? If the Earth has more mass, gravity would be greater. If the Earth has less mass, you know, maybe we would be taller people. You know, or the giraffes would be longer. You know, what effect do those things have on life? So yeah, some of those parameters out there do affect life, especially the heat, the mass, etc. Right? And but these people went with the constants that they had found through quantum mechanics. Okay? And so these are some of the issues that they brought up, okay, or that they were studying. Okay, and typical example here, I just give two examples. One is the fine structure constant, characterizes the strength of the coupling of an elementary charged particle with the electromagnetic field by the formula blah 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 blah. If alpha there, right, were to change by 4%, Okay? Stellar fusion would not produce carbon. We don't have carbon, we don't have us. Okay, so keep that in mind. So that carbon-based life would be impossible. If alpha were greater than 0.1, stellar fusion would be impossible, and no place in the universe would be warm enough for life as we know it. So just by changing that alpha, you know, which is a ratio 1/137, if we could change that number, they say that to some degree, right, life would probably have been impossible here on Earth. That's one of the arguments, okay? Otherwise, this cosmological constant, and again, there's several of these. Now, I'm just picking two here. And that's the dark energy of which space is made, and it overcomes, you know, the gravitational attraction of matter. Remember, Einstein said it was his biggest blunder when he included that cosmological constant. That's what that is. Essentially, it's, you know, gravity would pull everything together in the universe. Okay, that's what you would expect. And it turns out that Edwin Hubble in 1931, I think it was, he showed that, or at least this was his theory, right? Some people believe it, mathematicians believe it, that the universe is expanding. And galaxies are flying away from each other. Okay, everything is redshifted out there. That's the argument. And because everything is flying away, the universe is expanding, and you're saying, hold it. Then the gravitational the cosmological constant is actually, you know, a positive number, and all these things are being pushed away. Means that there's something doing that, and that's the dark energy that they talk about. It's that dark energy pushing mass away. When mass tries to attract mass, you know, the galaxy tries to attract our galaxy. What pushes it away, what overcomes that attraction, that gravitational attraction, is the cosmological constant, which is just a number for the dark energy, this invisible energy that allegedly pushes galaxies apart. Okay, so that's the general notion of dark energy. And here we have Nobel Prize winner Steven Weinberger, and he tells us why is this taking so long here? And he tells us why that's important for life or for death, for the end of man. So Weinberg explains that if the vacuum energy took different values in different domains of the universe, the formation of life-supporting structures would be suppressed in domains where the vacuum energy is much larger. Okay? Specifically, if the vacuum energy is negative and its absolute value is substantially larger than it appears to be in the observed universe, say a factor of 10 larger, holding all other variables constant, that would mean that the universe is closed. So they're talking about whether the universe is closed, open, flat, you know, that sort of thing. Its lifetime would be shorter than the age of our universe. We're already putting a limit on the expansion of man by saying, hey, you know, the universe doesn't go forever, okay? Possibly too short for intelligent life to form. Okay. In other words, on the other hand, a universe with a large positive cosmological constant would expand too fast, preventing galaxy formation. According to Weinberg, domains where the vacuum energy is compatible with life would be comparatively rare. So that would explain, maybe, right, why we can't find life out there. Maybe we are an exception. And so these people are trying to figure all this out through a mathematical angle. They're saying, okay, maybe the equations, maybe the variables, maybe the constants that we've got out there that they've come up with, been able to measure, they say maybe those have to do something with life, with this anthropic principle, the fact that they're fine-tuned for life. And it gives you an idea that these people really, without them knowing, they're talking about design. They're talking about a watchmaker here. You know, they're saying, look, it's just by sheer coincidence that all these constants are in such concordance with each other that it allows for life. Because if some of those constants were different, we wouldn't be here. And hopefully they don't change. Maybe they stay the way they are, because if they change, well, that's the extinction of man right there, you know. So hopefully, you know, the proton mass stays the same, electron mass, all this stuff, you know, the velocity of light, all that stuff hopefully stays the same, because if any of that were to change, well, who knows? Maybe that will kill us. So you see how they're bringing us in. They're saying, oh, we have to get into the extinction business because our math tells us that maybe, just maybe, this tells us something about why we're here in the first place and why we may not be here in the future if any of this happens to change. Okay, so that's where they're going with all this. So what happened? About 10 years after Carter wrote his 1983 paper, this fellow comes up, and he comes up with a doomsday argument that essentially is the most popular, the one that's being used today. Okay, and so what does Mr. Gott say? Well, essentially, he has this argument, and here I try to illustrate it, and it goes something like this. If I need this thing up here. Okay, you have two hats. Okay, you put 10 or 15 papers with numbers in them, 1 through 15 or whatever, in the top hat. And in the 10-gallon hat, you throw 1,000 papers or 1,000,000 papers, whatever you want. Okay, whatever fits. Okay. Now you ask someone to pull a number out of one of the hats. They don't know what number, what hat they pulled it out of, and they say, "Okay, I got the number 4." So they pulled the number 4. You look at it and you say, "Well, hold it. What hat do you think you pulled this one out of?" Well, if you have 1,000,000 papers in the 10-gallon hat, you know the likelihood of pulling out a 4 is almost incredible. No, you would say, "No, I'm more than likely, I'm almost 95% sure that I pulled it out of the top hat, because it's more likely to pull a 4 out of 1 through 15 than to pull a 4 out of 1 out of 1,000,000. Okay, so that's essentially the analogy that they use, and then they go into the extinction theory itself, and it's got to do with how much time we have left. Okay, and here is essentially my illustration of that. Okay, here it is. Okay, let's say you don't know whether you are one of the last humans on Earth or one of the first humans on Earth. In other words, how many humans have there been, and how many humans will there be ever? Assuming we're not eternal. Assuming we have say trillions of humans. Let's say we have 1 trillion humans or 10 trillion humans. Well, if we ever have 10 trillion humans, you are just a small percentage of that. You're in the 5% region. The 100 billion people that supposedly lived until today and died, they only form like 5% of all the humans that will ever live. And if we live in eternity, well, that number goes from 5 almost to 0. It approaches 0 the longer we live, unless the universe explodes or dies or whatever. On the other hand, if we're close to, if the 100 billion are almost all the people that are ever going to live, well, then maybe we're in the 90 percentile region. We are among the last humans to be living on the planet. That's the end of our species. So this is essentially the argument. Either humans are going to live for thousands and thousands of years, maybe millions of years, and we are just a small portion of the humans that will ever live. We started, if we assume like that we started 200,000 years ago, the 200,000 years form a small percentage of the trillions of years we have ahead of us. And so in that sense, we're only 5% or less of the humans that will ever live. On the other hand, if we are the last humans on Earth and the 200,000 years are essentially all that humans will ever live, well, then you're in the last group, and you're within maybe the last 90 or 95% of humans that will ever live. So that's essentially what the Gott argument was, the Doomsday Argument. That's the most popular. There are different versions, by the way. Okay? So, well, a lot of the criticism here has to do with, we don't know how many humans will ever live. All we can do is guess. And so, we haven't learned anything from math in this regard. This is just playing around with equations to say, well, what if? That's it. Does it tell us anything about reality? Does it tell us anything about extinction of man? It doesn't. And it doesn't because, again, we don't know how many humans will ever live. Do we have 1,000 years in front of us, 1,000,000 years? We don't know. We don't know if there's going to be trillions of humans or the 100 billion that we've got so far, 107 I think it is, 107 billion. That's it for man. Maybe we reach 110 billion and that's it. And maybe we've got 3 billion to go, maybe 2 billion, 1 billion. Do we know? No, obviously mathematics cannot tell us anything because this is a qualitative issue. But if they want to do numbers, they should have done numbers like I do. Okay, so here's my numbers. Okay, and I got these numbers. I just pulled them out of the Wikipedia, and these numbers reflect what the demographers have collected over the last 2,000 years. What they say happened as far as population. For the last 2,000, in fact, when you get to 2,000, you get even more variation between demographers. They start coming more or less together about the year 500. Okay, so that's when I started my calculation here. Okay, if I can get this thing up here. Okay. Okay, and so if you start at the year 500, there were maybe 200 million people on the planet. By the year 1000, we had 300. Remember, by the year 1500, we had a loss of people because of the bubonic plague. Millions of people died, maybe a third to a half of Europe. But we recovered that population more or less. By 1500, we had maybe 500. 1700, we had like 600 and so on down the line. By the time you get to 1900, okay, now we have to go by decades because, you know, we started increasing by the hundreds of millions, okay? And you can see the numbers just in the last 100 years, how they went up dramatically. And, you know, we were at 1900, we were at 1,600, 1.6 billion people. And in just 100 years, 120 years, we're up to 7.6 billion, maybe even more, maybe we're closer to 8 billion. So we've expanded rapidly. And I think this tells us a little more than what the Doomsday Argument tells us about, you know, where we're headed. And especially when you include this other graph, okay? Here's that pictorial version of that. I don't know why these things are taking so long today to upload. Okay, you can see what happened, just a pictorial version, okay? And so if you go in there and you look at the other piece of important piece of data that I include, and that's the declining birth rate. Since 1963, our birth rate, our growth rate has gone down. And by the year 2050, maybe a little further, if things continue as they are, we're going to reach zero population growth. That means, you know, population's not going to increase anymore. So maybe we reach 9 or 10 billion, and that's it. That's it for humanity. You know, we're just going to stabilize. We're going to remain more or less with the same population forever and ever, supposedly, right? And so if I put that graph that you just saw and I put it onto my curve of life, okay, the question is, what's going to happen after we reach that zero population growth? Are we going to continue growing exponentially or whatever? Are we going to oscillate back and forth, more or less stabilize on a constant population, maybe 9, 10 billion people? Or are we going to head down, like I say, all the way down to extinction, to zero? Which of those three curves are we going to follow? And yes, we are going to follow one of those three curves because there is no other option. We either continue growing, we stabilize, or we go down. Okay, that's it. And so it's up to you to determine, you know, which of those curves we're going to follow. And right now, like I said, you know, we are our growth rate is going down. So we're headed towards that point where I doubt very much we're going to take that exponential curve upwards. No, I think it's either going to be constant, more or less constant, oscillating around some value, or we're going to go down to extinction. And the one I choose is the one for extinction. Not because I'm a pessimist. No, I'm realistic. Okay, so it's not pessimistic, it's realistic. Okay, what's my point? My point is that you can't determine anything, doomsday, through mathematics. Mathematics was not designed to tell you anything no explanation. You don't have explanations in mathematics. All you have is descriptions, and these people are trying to get explanations out of values, out of constants that they've determined out there, okay? And so here's my conclusion on this, okay, for these mathematicians, okay? The Anthropic Principle is just an attempt to determine through equations whether the universe is fine-tuned for life. Well, that's like a bootstrap mechanism, like, you know, it's tautology. That's all it is. And the Doomsday Argument is an attempt to determine through equations, again, mathematics, whether the extinction of man is imminent. You know, they try to throw equations, numbers at the thing. And again, that's, you're never going to find out through equations. But you can find out maybe through the numbers, qualitative things such as, you know, the birth rate. That might tell you a little more than what these people are saying here. Okay, so that's, in a nutshell, what I think of their Doomsday Argument. And again, if you look it up, you'll find tons of literature that has been published in the last, I guess, 60 or so years on this issue of Doomsday and the Anthropic Principle. Absolute nonsense, but these people have nothing to do, and so they branched out into this realm, and it does create some job security for a lot of these mathematicians. I think that's all that is. Treat it with a pinch of salt. Okay, so let's go on to some of the questions and comments that people made. And so let's start with the first one. Okay, here it is. First person says, some people I talk to think that money would not be a problem. If the system collapses, animals finally live without money. It's amazing how far from reality some people are. Yeah, I agree. You know, it's people think that money is going to be there forever. People think that trade is going to be there forever. You know, everybody says, sure, I can trade. I have the free will to trade. That's if you have something to trade. See, these people should do a little investigation, a little research, going back into the past, the Paleolithic, and they'll find out that the hunter-gatherers never traded. If you decided to trade there in the jungle, in the forest, you were trading your life. No, every man did his own thing. They hunted their own thing. They did their own thing. They caught their own food, and essentially. They trapped and killed whatever they were going to eat. It didn't go beyond that. And so when we get to the asphalt jungle, if money disappears, okay, then what we're going to have is a very strange situation, because if you go out there and try to trade, well, you're going to be trading your life, and the guy's going to just take whatever you have. So, you know, you won't be able to trust anyone, okay? That's the law of the jungle. You don't trust anyone because you don't have either the legal foundation nor the military foundation to protect you. So now you're protected. You know, there's no 911 in the asphalt jungle. Okay, so if the money happens to collapse, like I say, there won't be any trade, because trade besides there won't be anything for you to trade. What are you going to trade? You're going to trade your car for a banana? The guy with the banana will win. You know, because he doesn't need a car, but what he's going to need is food. Okay, so food is the only thing that you're going to trade, and you're not going to trade food. It's not like you're going to say, well, I got chocolates and I'm going to trade for bananas. No, because that's your last chocolate. There is no more chocolate. No one manufactures or distributes any more chocolate. So whatever food you have in your fridge and your cupboard, that's a measure how much time you have to live. Okay, that's the argument. Okay, boy, these things are taking a long time today. I don't know why. Okay, so here's the another comment. You can't tell us how inbred along that we are, which is saying that you can't determine how we came about into a Cro-Magnon man. Any discussion leading towards our doom will use this as the determining factor. No. No, it's got nothing to do with anything when we started. And when we became Cro-Magnon, Cro-Magnon, by the way, is the name given to man as he entered Europe. Okay, so that's European man is Cro-Magnon man in the Upper Paleolithic. But it doesn't matter when we started. We could have started 300,000 years ago, 200,000 years ago. And by that I mean that our species started. And what do I mean by that? I mean that we could still have sex, viable sex, with someone 200,000 or 300,000 years ago. So if a man of today went to the past and slept with a woman of 300,000 years ago, and if they could produce fertile offspring, viable offspring, then they're from the same species, okay? And if they can't, well, then that's too far back. Maybe you got to go only 200,000 years or 150,000 years, okay? So that's the point. It doesn't matter when that point was. The point is it's a projection and saying, what is a species? Species is interbreeding. Means that that you can have children. If you have a tiger and a lion, they can have children, but they're not very successful at having, and also the child that is born is usually, or I think always, I don't know, infertile. So it can't have children. And so that's the end of the race right there. And why? Because the tiger and the lion separated too many years ago, okay? And that's essentially it. There's evolution, people or species being born in different ambience, like in the case of Neanderthal. Neanderthal was an Arctic gorilla. There's no way we could have had viable sex with Neanderthals, but tell that to the geneticists who found 2 to 3%, and they say, oh, that's why the Neanderthals disappeared, because they had sex with us. Okay, another comment. So this thing can get up there. I don't know why today we're having a problem with this. Oh, it was faster. Okay, here's another comment. Fossil fuels have been 80% of global energy for over 25 years. Electricity is 20%. Water stress will threaten 50% of thermal power capacity. 500 years ago, there were so many codfish, la la la, okay? 400 years ago, there were more Caribbean sea turtles. Goes through a whole list of data points. I just want to make sure that people understand this is not my theory, okay? This has nothing, my theory has nothing to do with the environment or the fact that we're destroying the environment or climate change or any of that nature. In fact, it doesn't have either to do with the fact that we lost genetic diversity. That has nothing to do with my theory of extinction for man. Theory of extinction for man is economics. Economics, okay? We will not trade because money will be no more and there will be nothing to trade except food. Nobody trades food in the asphalt jungle. And whatever food you have left, that's as much time as you have to live. After that, you start killing people and eating them, called cannibalism. That's what happened also to the T-Rexes. Apparently, they engaged in a bit of cannibalism at the end. You have Sue. She's got a couple marks, I think, on her neck or somewhere in her body that they say was an attack by another T-Rex, because who else could come up against Sue, right? So yeah, there's going to be cannibalism, murders, killing, robbery, you name it. Last humans will suffer, will not go to heaven. They'll be going to hell. Okay. Okay, another common question. In applying a rational explanation for existence, I underline some of these words, we are forced ultimately to the logical, rational, okay, conclusion of an obviously elegantly designed and created reality having been brought about by something that must exist outside that reality. We must say that entity is by definition supernatural, beyond nature, and we call that entity God. Okay? There is God, there is God's location. We have arrived at the bounds of our human ability to comprehend. Well, the big problem here is this surely cannot define any of those words. He cannot define existence, reality. He cannot define something, entity, okay? And for sure, he cannot define location. And until he can define those, he said nothing. Absolutely nothing. So you got to define those words in order to understand. And yeah, the issue is that no one in the last 10,000 years has defined, especially object and exist. We don't know what a thing is, what an entity is. We don't know what exist means, what existence means. And when I say we, I mean the mathematical physicists and all those who call themselves scientists, who never defined a single word. And in this site, what we do define words. And when we define them, yeah, a lot of this religions fall by the wayside. In fact, all of them do. Okay, let me go on with another comment question here. See what we have. If electricity isn't an object and magnetism isn't an object, wouldn't it therefore follow a conflation of electromagnetism be conceptual? If electromagnetism is a concept, would it therefore all follow that electromagnetic rose, being foundational, be an issue with physics that require a non-conceptual objects that have form? Well, yeah, we have a problem here because the fellow is not, again, defining what an object is and what a concept is. We have to define these words before we can use them. And this is the issue. The issue, I mean, what does conceptual object mean? What is a concept? That's like saying, that's an oxymoron, a conceptual object, because concept is not an object and object is not a concept. An object is that which has shape, and a concept is a word that invokes two objects. So object is to one what concept is to two. That's it. So that's how we define it. Now, if you got a different definition, well, start with your definitions. Otherwise, we can't have any idea what you're talking about when you say a conceptual object. What the hell is that? And again, people, what they do is they introduce notions of ordinary speech, and they say, well, a square, that's a conceptual object or a concept. No, a square is an object. It has shape, period. We're done. It meets the definition of object. Now you say, well, it's a concept. There is no such thing as a square floating out there in space. That has nothing to do with object. That has to do with the word exist. Now you're talking about existence. And for that, the object has to have location. So now you're not worried about the word object, entity, thing. Now you're worried about a different word. A word exists, which means an object that has location. So that's got to be clarified. You got to define, and then only then can you use the words consistent, and we can understand your question. Right now, we can't even understand your question if you don't define your terms. You got to define these terms, and no one has. And obviously, you should. Physics had to define these terms over so many centuries. It was the responsibility of physicists to define the words object and exist. Physics is the science of existence, and physics cannot be done without objects. Okay, next common question. The standard illustration of a sphere of mass pushing down on a 2D grid of space-time is simply incorrect. And deceptive. The grid should be getting pulled inward towards the center of mass of the sphere in all directions to be correct, and is much better illustrated with a 3D grid. Animating this and moving a semi-transparent Earth-like sphere back and forth through a 3D grid would clearly illustrate this, and even more clearly if gravity in the animation was turned off and on while moving the sphere through the grid as well. Okay, so let's find out if what this gentleman says is anywhere in the ballpark. Okay, here we have the 3D grid that he's proposing. Okay, if I can get this thing in there. Oh, why am I having so many problems with this today? It's getting stuck to my, I still can't get it in there. Hold on, give me a second here. Okay, there it goes, I think. Yeah. Okay, here's the Earth, and here's the 3D grid being pulled towards the center of the Earth. Why is that grid being pulled towards the center of the Earth? That's the first thing you got to explain, or even before that, you got to explain what is that? What are those blue lines? That grid? What is that thing? I mean, what is that so-called space-time? What is it made out of? What is time made out of? Is it made out of bricks? I mean, if you're going to warp it, you're going to go in a direction or something along the time dimension. What is this time dimension? Is it a yellow brick road or of some kind? So the first thing is, here we have the Earth, and it's pulling all towards its center. You have to answer, what is the grid? What is that stuff? You got to identify. You got to identify the black stuff that gives shape to those threads of the grid. okay, to the fishnet. And then you got to tell me why that grid is going towards the center of the Earth. Why is it? Because of mass? I mean, you know, when Einstein came around, he overruled Newton. He said there is no such thing as force. So what you got to explain is why the grid is moving towards the center of the Earth. What's pushing it there? What's bending it in that direction? And so here, let's do the one for the sun. I hope I can get this thing in there. Okay, here's the grid for the sun. Same thing, same questions, same issues. Okay, and now let's put them both together. Okay, let's find out if what this fellow says is true. Here's, oh, come on. Here's the Earth and the sun. They each have their own grids, okay? And so you wonder, you know, what is that black stuff that is between the fishnets, the threads, the ropes, or whatever that form the fishnet? What is that? What are the blue things? What are the blue lines? What is that fishnet? And why are they being pulled towards the center of the sun, and why towards the center of the Earth? And then wouldn't that pull the Earth inwards? And yeah, you could argue and say, well, because the Earth is trying to fly out of that, and you know it spins around the sun, that's why it's not being drawn towards the sun. But then we have a problem, because again, we're talking about force. Okay, we're talking about a force being pulled on the Earth. Because here, the sun is not weighing downwards as in the typical illustration. Here you're saying, okay, the sun is pulling all this inwards. It should pull the Earth, but what is it pulling with? With a two-dimensional scenario, you can imagine the sun weighing down space-time and the Earth trying to roll down towards that depression. And it doesn't fall down there because the Earth is rolling around the sun. Fine, the analogy we can understand. This analogy we cannot understand, because you have to introduce force, which is what Einstein said is not true. There is no such thing as force. Gravity is the bending of space-time, essentially. And here, don't take my word for it, here we have proof. If I can get this thing up here. Jesus Christ, today I'm having trouble getting these things there. Here we have the version from NASA, and I mean, you can't get any more authority than NASA, right? I mean, here it is. NASA says, you know, it's the warping of space. And the Earth pushes down the canvas, and that's the reason that the satellite goes around the Earth. So it's not a force. And what anyone who illustrates a three-dimensional, what do we call it, fishnet, canvas, whatever, is has no idea what the equations of general relativity say. That's not what the equations say, because what you're doing is introducing force, and that's what general relativity did away with. Newtonian force, which is what you're trying to introduce here. So the three-dimensional scenario that some bean brains out there illustrate, saying, oh no, that two-dimensional, that's ridiculous, that's so realistic. I've got the real one, I've got the three-dimensional one. No, you're the bean brain, because that means you didn't understand the theory, you don't understand what Einstein proposed. What Einstein proposed, whether people like it or not, is the geometry of space. That's or space-time. That's essentially what the equations say. Einstein didn't say that with his own words. I want to clarify that. But that's what everybody got out of it, and that's what's important. It's what people spread around today. And those are the people who get Nobel Prizes. All these people who do 3D fishnets, they have no clue. They have no clue whatsoever. They're just trying to be smart, and they say, oh no, I know better than these mathematicians. You know, I do the 3D fishnet. Whatever, you know, I mean, that's just a sign of ignorance when you see that. And you should put that in their when they put a video on that, tell them that they're ignoramuses, okay, please, on my part. This guy says, prove that the Earth is a sphere in outer space. Prove how the sky can be an infinite vacuum void. In science, we don't prove. You're confusing mathematical physics, you know, the mathematical scientific method, So they say, okay, it's a mathematical method, no science about it. They do proof. So you're in the wrong forum here, in the wrong channel. Proof belongs to religion. Okay, we don't do proof. We don't prove anything. What we do is make an assumption. We say, let us assume the earth is a sphere. Is that good enough for you? I mean, I don't have to prove that the earth is a sphere for anything. What I do is say, let us assume the earth is a sphere. Some people might say, but the earth is a sphere. Irrelevant. We make an assumption. Let's assume the earth is a sphere. In fact, you don't like the earth because the earth is too touchy a subject. Let's assume the moon is a sphere. Let's assume Mars is a sphere. Let's assume Jupiter is a sphere. How's that for assumptions? Okay, we've never been there, so we can say, well, let's assume it's a sphere because it looks round out there, the moon, right? So I can make that assumption and say, let's assume the moon is a sphere. And now, is that the theory? No, that's an assumption. The theory is, let me explain gravity to you. Let me explain why things fall to the center of the moon. If I let go of the hammer and the feather, like the astronaut, why do they fall down? That's what I got to explain, okay? So assumptions, that's what it is. You can also make an assumption about God. You can say, let us assume God exists. Okay, no problem. What are you going to explain? It's the explanation that is the part of science, the theory, the objective explanation, not the assumption. You know, the things, whether space is infinite or not, you know, that's the secondary part. First, you got to identify the objects. And then you make an assumption for those objects. You can say, let us assume space is made of particles and that it's infinite. You can make that assumption. No problem. I mean, does that mean that that's what it is? No, that's what is for the purposes of your theory. That's your assumption. That's how the scientific method works. The mathematical method works a little different, okay? Okay, another comment question. Alexander Graham Bell said he didn't invent the telephone, it already existed. What was his name? Meucci, Italian guy, invented it many decades before then. There was a fight there, because when Graham Bell patented his telephone, this guy said, hey, no, I've got a prior patent on this. And apparently he didn't have the money to sue Graham Bell, and then he died, and so that was the end of Meucci. And the guy who ended up with the credit was Graham Bell. And today, because he's the guy who became rich with this guy's invention. But Meucci is the guy who apparently made the first working phone. It wasn't a perfect phone. It was like 1847, I think it is. His wife was on the second floor or something like that, and he created this telephone so his wife could communicate with him and call him, say, look, I'm in problems. She was paralytic or something, and so he developed this device, and that's, I guess, the first telephone. But it never became popular. He didn't make any money off of it. By the time he tried to sue these people, he didn't have money even to file the application for the patent or to sue a Graham Bell, and then he died, and that was it, the end of Meucci. That's life. Okay, that's history. Okay, another comment here. Or a question. Let's see if I can get it up there. Okay, a fellow says, energy can neither be created or destroyed, always has been and always will be. Yeah, because there is no such thing as energy. Energy is a concept. And so you can't talk about the existence or creation or destruction of that which is a concept. I destroy concepts every day. I mean, you know, concepts are easy to destroy. The issue is, can we destroy matter? Can we destroy atoms? Can we convert them into nothing? Can we take that which has shape, for example, 3D shape, especially length, width, and height, and turn it into that which doesn't have shape, that which lacks length, width, and height? Can we take something and turn it into nothing? That's the issue. But energy is a concept. We destroy that every day. I know a lot of people destroy love every day. They get divorced and they're destroying love. Other people destroy intelligence and so on. Yeah, I mean, destroying concepts is easy. And all concepts will be destroyed the day man dies, because man is the source of all concepts, okay? See if I get this other comment up there. Okay, and let's see. It says, universal collective consciousness. All is everything and everything is in all. Yeah, consciousness, concept. That's what they should call it, conceptness. Okay, there's no such thing as consciousness. In science, especially in physics, what we have to do is identify the physical objects, and we have atoms inside the brain. Hopefully, some of us. Others don't. They have consciousness. They don't have atoms in there. But we have atoms. Normal people have atoms in there. And it's those atoms that create this thing we call thought, mind, consciousness. All that is just a process. It's a verb. And it's an abstraction. And so, no, there is no such thing as consciousness. Like out here, we can't bring consciousness and bring it out here and say, here's consciousness, because then it would be an object. Okay, so no, consciousness is a useless word, especially for physics. And people who raise those issues should go into religion, not into physics. Okay, they're obviously fooling around in the wrong channels. Okay, and last comment here, if I can get this thing up here today. Jesus Christ, it takes so long to upload these things. Okay, question about the rope theory. The rope theory, whoa. If the threads cause gravity in light, why does light get blocked by objects? If my atoms are connected to the sun, should not the light reach me no matter what? Well, I could answer this question, but I've got a more fundamental issue, and that's obviously, the answer to this question is in the book, which is in the description. Okay, the rope hypothesis, downloadable. You can read it. It's a PDF file. And obviously, this fellow hasn't read it because the answer is there. That's one issue. But then the other issue here is that you can tell that he hasn't read it because of the rope theory. And no, it's not the rope theory, it's the rope hypothesis. And if you don't know the difference between a hypothesis and a theory, well, you got a long ways. Rational scientific method does not confuse theory with hypothesis. And if you go to the beginning of this video, where I talked about the rational scientific method, you'll see the difference between a theory and a hypothesis. And with that, I will see you Wednesday.